In this video, we will discuss the problem overlapping intervals. The problem says that we'll be given an array and the ith element of the array will tell us about the starting of the ith interval and the ending of the ith interval. The task is to merge all the overlapping intervals. Previously, this question has been asked in companies like Google and Microsoft. So let's have a quick look at the test cases that have been given here. So basically, if you look at the very first test case, that is, if you look at the very first test case, that is 1, 3. Then after that, we have got 2, 4. Then after that, we have got 6, 8. And then we have got 9 and 10. So if you see this particular test case here, so we have to merge all the overlapping intervals. Now you can obviously see that if we draw all these intervals on the number line, then 1 and 3 and 2 and 4, these intervals are definitely clashing with each other. These intervals are overlapping. Then after this, if you will see next also, so then 6 and 8 are not overlapping with any interval and 9 and 10 are not overlapping with any interval. So there is only one pair of intervals that are overlapping with each other. So for these two intervals, we'll merge them and we'll write 1, 4, and the rest of the answer would be 6, 8 and 9, 10. So initially we were given how many intervals? 4 intervals. After merging, we have got only 3 intervals. Okay, now what will happen here is, let's say if we have the second test case. So let's say if we have got like 1, 5, I'm writing them in the sorted order of the starting so that I can iterate from left to right order for the intervals so that the checking is much easier. Now after that, if I write 2, 4 here, then we will write what? 4, 6 here. And then after that, we'll write what? We'll write 7, 8 as well. So if you see, the thing is that equality will also be considered for overlapping, because if this interval is ending at 4, another interval is starting at 4, so this will be considered as an overlap as well in this particular problem. Now what will happen here is, if you can see, so all these three intervals can be said that they are overlapping, because 1 and 5, it is overlapping with 2 and 3 as well as with 4 and 5. So overall these three intervals are overlapping. So that is why what we can say is that instead of these three intervals, we can simply write one single interval, that is 1, 6. So we can take the starting as 1 only and the ending will be taken as the maximum, which is nothing but 6. So we'll take 6 here. Okay, then after that the next interval is 7, 8, which is not overlapping with any of the other existing intervals. So the final answer would be 1, 6 and then 7, 8. How can we solve this particular question? For solving this particular question, there can be many approaches. First and the simple approach is that with respect to a particular interval, we check its overlapping with the rest of the intervals. Okay, now this is very brute force, because what I'm saying is, if I am at a particular, let's say, ith interval, so I check it with all the other intervals, if it is overlapping with all the other intervals or not. If it is overlapping, then I take care of that overlap, and after that I give one combined interval. Okay, now if I do this for a particular index, that would take order of n time. Since I'll be doing it for all the I indexes, so that would take n square, because for one index it's like I'm iterating the rest of the n minus 1 intervals, so the time complexity would be order of n. But since I have n indexes, so this would take order of n squared time here. So let's see how we can do it. Let us say that if we have got this particular question, that is, we have got 1, 4 here. Then after that, we have got what? We have got, we have got 1, 3 here. So I'm sorting the given intervals on the basis of the starting time so that we can iterate easily from the left to right order, and we can get a feeling of number line where the very first interval is having the least starting, and then we keep on moving forward. Now if you see, we will do what? We'll write 2, 4 here, then we'll write 6, 8 again, and then we'll write what? 9, 10 here. Now what will happen here is, initially in our result, initially what will happen is, we'll be at this particular interval here. Now the moment we are at this particular interval, so we'll start our j index from the next one. So if you see, currently the starting is what? The starting is 1. Okay, so we'll say that the start is what? The start for this particular interval is 1 and the end for this particular interval is what? 3. Now we'll check it starting from the next. So we'll start a j variable which will be indicating the next intervals, and will be here. Now when we are at this particular interval, you can observe that this interval is overlapping with the previous interval, because if you see my starting is 1, ending is 3, and this interval has got starting lesser than the ending. So that is why this interval will overlap. So now I'll update my endpoint to what? Endpoint would be updated to 4, because it's like I'm merging these two, but I'll not merge them directly. I'll just update my end to 4, and I'll look at the rest of the intervals also for this particular ith interval. Now when my j will move forward, it will be at 6, 8. It does not overlap, so no worries. Then my j will move forward, it will be at this particular interval. It does not overlap. So no worries. And we can simply say that the start and the ending is 1 comma 4 for the overlapping interval here. And we can simply update it in the result. So now what will happen is after this, my result will get updated with 1 comma 4 because this is the very first merger that I found out when I was iterating for this particular interval here. So what will happen here is in my result, we'll simply update one interval that is nothing but 1 comma 4. Now the moment I go to the next interval, I see that this interval is 2 comma 4 and currently I'm having 1 comma 4 already in my result. So this means that I can skip this particular next ith interval that is 2 comma 4 because it has been already processed during the overlap checking. Okay, so then we'll move forward now here and we can skip this interval because simply it is already stored in our answer in overlapped condition. Okay, then we'll go to this particular interval. Now for this interval, we'll check the rest of the intervals also. Now when I check the rest of the interval, so you can observe that this particular interval will not overlap with any other interval. So the starting and the ending would be the same. So after the iterations are over, we'll update it as 6 comma 8 in the result. Okay, then what will happen is next time when my I will be at the last interval here, this one. So when we'll check, there is no overlap obviously. So 9 comma 8 will also be updated in the answer. So the thing, sorry, 9 comma 10 will be updated. Now you can observe that for one particular index, for one particular ith interval, we have to check the rest of them. Okay, so this is taking a lot of time. So for one interval, for one ith interval, we are taking roughly order of n time. So for n intervals, it would take n square time. But this is brute force. Initially, what you will do is a simple approach is to group all the intervals by sorting them according to the starting time for the first interval, and then compare it with all the other overlap. So basically, you will start from a particular ith interval and you compare it with all the others, and you check the overlaps. And at the end of the day, if there is if the first interval overlaps with any other interval, then remove the remaining other intervals from the list and merge it into the final interval. So as I said, if there are overlapping intervals, so it's like you are merging them. Okay, you are making one combined single interval. Okay, and you repeat the same process for the remaining of the intervals. So as I said already, if you were at 1 comma 3, then you check thoroughly and you were finally able to generate 1 comma 4. Now since you have generated 1 comma 4, so when you come across 2 comma 4, this interval, so this is already processed because 1 comma 4 is already written in the result. So since the result already has an interval which is catering this range, which is having this range, so then we can skip this particular interval. That is what approach says here. So this particular approach would take order of n squared time, and the space complexity would also be order of n in case if I'm making a new resultant list to store the final answer here. So let's have a look at the code here and see what we can do here. So basically, firstly, we'll sort the array according to the starting time here. And after that, we have a result ready as empty list. Okay, then we have the starting of the ith interval and the ending of the ith interval. Then after this, if what happens is, if we are at a particular ith interval, okay, which has been already processed in the result, then we need to continue it. Okay, because if there's a particular interval that is, if the last interval that is there, the latest interval that was stored in my result, okay, if it is overlapping with the current ith interval, then in that case we can skip processing this particular ith interval because it has already been written in the answer. Otherwise, what we can do is we can start a j loop from I plus 1, that is from the next interval till the end, and we can check that for whichever intervals, if the starting time is lesser than equal to the ending time, then we need to merge those intervals. So we need to keep a track of the ending as the maximum. So what does this mean? Let's say if I had an example like I had 1 4, then I had something like 2 3, okay, then I had something like 3 and 6 as well. Suppose if I had this particular test case here, you can observe that all these three intervals will merge. Okay, so basically what is going to happen is my start is 1, end is basically 4 right now. Then what will happen is when I go to this interval overlaps. Okay, and if I'll check the maximum ending, so out of 4 and 3, the maximum ending is 4 only, so I'll not update anything. And after this, we'll go to the next interval, that is this one. Okay, when we check, so the starting is basically lesser than the ending here, so this will also overlap. So we'll update the ending with the maximum of the current ending and the ending for this ith interval. So we'll update it with 6 here. And that's how you can see that the start is 1 at the end of the day and the end is basically 6 here. So this is what you can observe for the test case here. This will be the brute force approach that we can apply. But this is taking a lot of time because we are doing a lot of redundant checking. So instead of redundantly checking, we can do what? We can check the current interval with the last interval that we have processed already. Okay, so that we don't have to check we don't have to check the intervals again and again which have been already processed. So let's have a look at that approach also. So basically what you can do is you can optimize your approach by just applying sorting. So you will not iterate n square times here. What you will do is you will focus on iterating only a single time. Now how will you do that? Basically you will always check the current interval with the last merged interval in the result. Now what does that mean? Initially if you see this test case, so we have sorted the test case according to the starting time so that we can iterate easily. Now in the result, what will happen is we'll update the very first interval. So that is 1 comma 5. And we'll currently this is the latest interval that we have. Now currently if suppose that I am at 2 comma 4. If I'm at this interval that is 2 comma 4, does it overlap with the latest interval with the last merge interval? Yes, because the last merge interval is 1 comma 5. So this is ending at 5, but this current interval is starting at 2. So it overlaps. So if it overlaps, then I'll check the ending. So the ending here is 4. The resultant already has got ending 5. So the last merge interval has got ending 5. So we'll keep 5 with ourselves because the better ending is 5 only. We'll take the maximum here. Then we'll go to the next interval here. The moment I go to the next interval, what happens is I'll be at this particular interval. Now when I'm at this particular interval, it's 4 comma 6 here. Now does it overlap? Yes, it does overlap because I've got 5 here as my ending for the last merged interval, and I've got 4 as the starting. So the ending of the last merged interval is greater than the starting of the current interval. So that's why there will be an overlap. So the ending will be updated to the maximum of the two endings. So out of 6 and 5, what is the maximum? 6. So my resultant ending as of now, the ending for the last merged interval would be updated as 6 here. Okay, then we'll go to the next interval. So now 7 comma 8 will behave as my current interval. Does it overlap with the last merged interval? The last merged interval is 1 comma 6. So the ending is 6. Does is it greater than the starting of the current interval 7 comma 8? No. So 6 is not greater than 7. So that's why there is no overlap. So we can safely put this particular interval as 7 comma 8 in our result, and this will be now considered as the last merged interval in our result. Then what will happen is when we'll proceed further, so we don't have anything, so that's why we'll just return this list here. So always whenever there is an overlap, we'll always update the ending for the last merged interval. But if there's a interval, if there's a current interval which is not overlapping, then we'll directly update that in the result, so that can be treated as the last merged interval here. Now the time complexity for this code would be how much? If you observe, the time complexity for my code would be order of n log n, because we'll be obviously sorting basis on the basis of starting time. Space complexity would be order of n, because here what I'm doing is I'm creating a resultant array to generate my answer. Now let's talk about one more optimization. Suppose that if you know how to solve this problem using this approach, still what you can do is still you can do in place in place merger of the overlapping intervals. Suppose that if you just had the given interval array, so what you can do is you can just manipulate the new result in that array only instead of taking resultant. For this problem, when we'll be finally submitting, then we can definitely return resultant array. But if the interviewer says that we have to solve this problem without taking another resultant array, we can do that also. How? See this. But before that, let's have a look at the code for this particular approach also. So if you will see here, what will happen here is basically initially my array will be sorted on the basis of starting time. Result will be initially empty. Then I'll update the very first interval as the latest interval that is merged. Okay. Then after that, we'll check the last interval from the result, and we'll also process the current ith interval that we are at. Now, if the current interval, if it is having starting less than equal to the ending of the last merge interval, so this means there is an overlap. So if there is an overlap, so the end of the last merge interval would be the maximum of the last merge interval ending, comma the current intervals ending. But if there is no overlap, then in that case we'll say that in the result we'll update the current interval as the last merge interval, and at the end we'll return the result. But like, suppose that if we have to do this in place without taking extra resultant array, then also we can do it in the given ARR array itself. What we can do for that is, suppose that if we have been given this particular test case 1, 5, 2, 4, 4, 6 and 7, 8. Now if we do not take any resultant extra array, still we can solve this problem. How? So you can see here that we will have a resultant index initially standing at 0, and my ith index will stand here. Now ith index will always indicate the current interval. Now what will happen is, since this interval is overlapping, so we'll do what? We'll update the resultant interval index with the endings. So if you see, there is an overlap with the ith interval, but the ending will still be 5, because out of 5 and 4, 5 is the maximum. Then we'll proceed further here. Now what will happen here is, then my index will move here. Now the moment my index moves here, 4 comma 6 is standing here. Now does this interval overlap with my resultant index right now? Yes, it does. So this means that there is an overlap here. Now ending would be updated to the maximum of the two. So the ending would be updated as 6, because out of 5 and 6, 6 is the maximum. So this will be updated as 6 here. Then we'll do what? Then we'll go to the next index here. That is the next interval. Now when we are at this particular interval, what will happen here is, if you will observe, this interval does not overlap with the resultant index interval. If it does not overlap, then we'll say that okay, we need to move our result forward, and then we'll update 7 comma 8 there. Okay, so this is how you will do it. Basically, see, you are updating the resultant index first of all, and then you are updating at the resultant index, you are updating the ith interval that was not overlapping. So what you will do here is, basically, you will update your resultant index first. So res will move here, and then here you will overwrite with the ith interval. So 7 comma 8 will be written here. And what you can do is, basically, you can return the result till this particular index only. Because if you see, you can if you return the result till this resultant index only, that is 1 comma 6 and 7 comma 8 intervals only. So they are actually reflecting what? They are reflecting the final merged intervals only. So this is how you can do it if the interviewer will ask you that how you can do it without taking extra resultant array. But when we will be submitting, so since the question is expecting us to return a list of only the resultant final intervals, so that is why we'll make a resultant list in this question. So let's quickly try to submit the code here. So we have written the code. Let's try and submit this. So you can clearly see that my code is getting accepted. I hope that you have understood this clearly. Make sure to mention your understanding in the comments. Thank you for watching this video.